Right. So this is like a general lecture about memory devices. So it's not nothing to do with programming, nothing to do with the microcontroller that we use. But memories are used in all microcontrollers, are used in all PCs, microprocessors, and so on. So just we talk about this device, this very important device. So we start with some memory terminology, and then the operations that we can have in memory, which are basically read and write operations. And then we'll talk about how this device is connected to the microcontroller. Inside the microcontroller, we have the CPU, right? Central Processing Unit, processor, or microcontroller, how it's connected to the CPU. And then we'll talk about the two types of the memories, the read-only memory and the random access memory, or RAM, ROM and RAM, with some examples. Right. So we start with some memory terminology. So as you know, memory is used to store the binary data in large quantities, of course, especially with the recent devices, very huge, sizes. Each storage element in memory can retain either 1 or 0, bit 0 or bit 1, and it's called a cell. So basically, if you think of a memory like a table, I think we talked about this. So we have a memory, a table that has many rows, and each row consists of what we call cell. This is a cell. So cell, we can store 1 or 0 here. So we can have values like this, 0, 1, 1, 0, 0, 1. So this is a cell. This one is called memory word. Memory word. Or we call it as well memory location. One memory location or one memory word. So the memory word can be, it's usually a power of 2, so it's values between 8 to 64, around 64. So depending on the memory that you use, right? So a memory contains a number of memory words, and each memory word consists of cells. So it could be the size of each memory word could be 8-bit, 16-bit, 32-bit, 64-bit, and so on. Right. And you can make customized in VHDL. You can make customized memories. You can have 4-bit. You can have 1-bit, 3-bit. You can describe you can create your memory, custom-made memory. So this is memory word. So we have cell, we have memory word, and we have the capacity of a memory. So the capacity or density of a memory represents how many bits can be stored in this memory device. And it is usually represented as the number of words by the word size. So for example, if I say this, I put an example here. If I say a memory of size 4096 by 20, this means I have 4096 words, and 20 is the size of the word size, or the word of each size, or the size of each word, sorry. So 20 is the word size, and 4096 is the number of words. So number of words. As you know, I think we talked about this. You know what is one kilo? 1 kilobit. If we say 1 kilobit or 1 kilobyte, what is 1 kilo in digital? We refer to binary. What is 1K? What is 1K?
1024.
Huh?
1024.
Which is here, yeah? So which is a power of 10. It's 2 power, oh sorry, power of 2. It's 2 power 10. 1K is 2 power 10. So if I say 1 kilobit, so 2 power 10 bits. So 1024, 1024 bits. If I say 1 kilobyte, and you know what is a byte, yeah? 1 byte is 8 bits. So it's basically 2 power 10 by 8. Or it's 2 power 10 bytes. If I want it in bits, then it's 2 power 10 by 8 bits, right? So you can have it in bytes, you can have it in bits. I think we did this in the other course, yeah? The digital. Now, of course, we have other, units. It's not just K, 1K. We have as well. We have 1 mega. Would be megabytes or megabits. So 1 mega is 2 power 20. We have 1 giga. And I think you heard about this gigabyte a lot. It's used a lot nowadays because the sizes of the hard drives and the memories now is huge. So we go for giga and we go even for terabytes. So it's 2 power 30. 1 tera is 2 power 40. We have even 1 peta now, which is 2 power 50. Right? Again, we talked about this in the previous course. So we express the capacity of a memory in this way, and of course, we usually refer to a memory with the number of words by the size of each word. So if we mention those two numbers, then that's it. We can get everything about the memory. And of course, including, we'll talk about this later on, because we need the data bus, we need the address bus. So all this information, the size of those buses, you can get it easily from those two numbers, just those two numbers. Is this clear? So when we say a memory chip is specified as 2K by 8, how many words can be stored on this chip? How many words we can store? What is the size of each word? Yes, Mohammed.
The size of each word is 8.
So this is 8. The size of each word is 8. Good. And then how many words can be stored in this memory?
2 times 10. 2 times 2 to the power of 10.
So it's 2K, which is equal to power 11, right? 2 by 2 power 10, which is equal to 2 power 11 words we can store in here. Right? Okay, good. And then what is the capacity? We just multiply 2 power 11 by 8, which is equal to 2 power 15, right? Which 2 power 14, because 8 is 2 power 3, right? So 2 power 11 by 2 power 3, which is equal to 2 power 14. So this is the capacity. Of course, this is in bits. If I want to specify it in bytes, so it's basically 2 power 11 bytes, which is fine. Both are correct. It's 2 power 11 bytes or 2 power 14 bits. Is this clear? Right. Now we are still with the terminology, the address. So like the tables, for each table we have rows. So we start from row 0 and then we go down until, the last row. So if I have a memory with 8 words, so we have word 0 until word 7. So basically we have row 1, 0, 1, 2. So this is memory location 0, 1, 2, 3, 4, 5, 6, 7. So for each, in the case of memory, we call this not the row number, but we call it the address. So for each memory, there is, in each memory location or each memory word, there is it has an address, a unique address. So 0, and of course we represent this in binary. Since I have 8 locations, so I go from 0 to 7, how many bits I need here? 3 bits, right? 2 power 3 is equal 8. So I need 3 bits. And this is what I'm using here. I'm using 3 bits for each memory location, or the address of each memory location, until 111. Right? So in general case, 2 power n for x is equal to power n, where this n is the number of address lines, or the number of bits in the address, the number of bits in the address, and x is the number of words, right? So this is general case. X is equal to power n. So if I have x, if I know the number of words, I will know how many bits I need in my address, right? So this is an example that we put here. A simple memory has 8 words. The address